So it works. Then okay, this modifications, then we have a small, see that nothing is there. So this is our test classes, and this is model classes. I try to explain the other part of the application. That's I mean, that's what we already discussed about that ones, different types of maps for the different functionalities. That's I mean here. This is the part of the applications. Let's see. But I need to change something in the navigator. You can go back every time. You don't need to go back. You can just refresh it and then do something. But I need more things to be this level. So here our top levels. What I here explain a little bit here, the more CSS, more functionalities, that programmatically part that's we did here. Let's see. GeoMap portal, the components we need to be look for, the GeoMap portal components. So this is the HTML page. So this is just very simple, just to call the maps. The maps has all information to render or to call the services and fill the your object into the maps, and then just call this target maps and then CSS class. And this is the CSS, then nothing there. So this is the most important. So here's unnecessary some input information, just I needed somehow some reason, but later I will remove it. It's the same. We set it central coordinate points. We did our necessary maps, sources, layers, views, markers, and then we set it our coordinates definition, and then we set it coordinate points and transform these coordinate points that you saw into the debug tool, development tool. You see the coordinate points changes here. This is the points of coordinates point changes. You can do whatever you like to do. There's a lot of functionalities you can do. Just one example. So here is the modify the dummy features, and this is the object. So you see the difference between the modify these features. There is a multiples, how can say multiples geometry system. So multiple layer and the styling. So this is the styling for the address information. You see the colors red, fill reds, and then you can change it here, RGB transparent colors for this one. So you can see the colors, maybe colors to change something, I don't know how is it called it, like you can set it here at 0, 0, 0. Let's see how is the effect. You see that color changes. Is brilliant. So maybe the transparent color, we can, could I write it here red, maybe something. I didn't check it yet. Maybe let's say let's do together without transparent. Yes, brilliant. It works. Yeah, it works. See that changes the colors. It works. And then so we go back to the here. So it's RGB colors to change the transparent in bit, see the behind the scene, how it's it look like. Yes, it's okay. Then this is the style for the address, and then all the geometry information is through storing the coordinates points and returning the coordinates, what we need to do in the log, or if I need in the future in the somewhere the geometry object, you can put it in geometry object. Basically this geometry object I need when I fill the forms in the coordinates points. And this is the plot geometry points. You have the different colors. So the plots, you see the colors, you can see here is also the transparency in behind the scene. You see that, because I see that it's simulated one, it's not the real one as I expect. So the plot geometry, and this the color is red, even though we can green colors, maybe the styling is a green, I don't know how it's called. It's green, maybe possible. Okay, it's okay. It's also okay. So you see the color effect of your nodes points. Your polygon edge and the node points is a green. It's okay. So here's the style for the buildings, all things red, and then you have the floor style, and then this is the most important one. So here's one of the example that I start to simulate here. That's one of the example. So you see that I simulate here. Not this is the simulation data. You can put it here like once. You can do it once. What you like to do, and then that means I make a simulator to run dummy plots, buildings, address, floor units. If I have a real data, I will replace the for loops and I will call the services and build the real geometry, real shapes, real register objects, real register address, plots, and that's one. Because I said it's legal issues to build the real legal geometry. When the application is deployed into the client machines and client has legal issues, he has legal powers to put it real objects and that real registration, and then you can real object into the maps. That's the idea. But let's see the effect of the what the simulator works. That's like running the simulator, build some sort of information out of the programmatic, out of the to demonstrate you how its application what test the applications. Test applications. Let's see what's the address. Okay, we do change the address information. Oh, isn't you see the only one address informations. So this is simulator did. So you can do hundreds, thousands. Let's see how is it slower, getting slower. I didn't did the load testing at the moment yet, but it works. Let's see how it is done. Okay, you see the rendering, it's a little bit slower. You see the effect of the, oh my goodness. You see the how effect is it? See the rendering, the programmatical. You see, school. So you see the object is really built. So let's have let's do the play with that one. So hundreds. How is it? But this case, I said that this is the needed licensing power, because for OpenStreetMap, no restriction. If you do this, then you see the effect is this one. So cool. This is the simulated address information. But it is not real case, but real case will be this one is the real object. For this case, not the simulated one. For demonstrating or for testing the software, this is good information or good idea to do this way. So I collect. That means here the address services is called or microservices call and fill the object in here and build the necessary information. So just store the coordinates points. This is the most important. This is the coordinates point coming from the database, the service. We define the necessary variables and define the coordinates from the service. Here at the moment it's hard coded, but this works. So we randomize generate the random value and put the fixed value into each of the iterations and draw the features. And the features this is the most important. You need to be take care. So this is one of the really tough part when you do the geoprocessing. So that means every projects, every models, you need to be bypassing. That means when you in the address level, when you're addressing here, then you need to be bypass this one. So when you click it one of them, then you can see the address information here. But this part is still not implemented. But here I saw some implementation is done. Some just like to give it to you impression how it's look like. You see the impression like so. Address ID and address reference ID 20,000 and 100,000. So see the impression, but it is not that we expect. Maybe here click button and make a special really beautiful pop-up somewhere, something beautiful way to do. But now we get started to implement these features. So this is the objects for the object model that we pass it here. That's I said the object model into our input models in here. These object models. This is the object models. Everything is there, and then just we put it these object models as a definition. This data is coming from the backend server, from the service call. We transform the coordinates points from the meter to the degree, minute, seconds, and then we source our vector resources and define the resource that we define here. You see the define here, and then we define our vector resources in the vector layers, and end of the day add this layer into the vector. So That means you have a 5 layers. So we have address layers, plot layers, buildings layers,